Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic, that is 9.6 young double slit experiment. Uh, what is the purpose behind this experiment? First, look into the history. In 1801, Thomas Young performed his famous double slit experiment, which provide experimental evidence in the favor of wave theory. Means this Thomas Young supported the wave nature of light. So he supported the wave nature of light as the Hygiene's principle supported the wave nature. Okay. The principle of this experiment is based on division of wavefront, means the wavelength, because the principal phenomena here is diffraction. Diffraction is the principal phenomena here in the Young double slit experiment. So it means that it is based on division of wavefront or wavelength. Okay. And you know that diffraction is proportional to interference. Diffraction is proportional to interference, means whenever the diffraction occur, it will interfere, the waves will interfere, produces will dark and bright spots. In constructive interference, bright spot will produce, in destructive interference, a dark spot will produce. Okay. So why this experiment is performed? Remember, we are going to find the wavelength of light. We can find the wavelength of light in this experiment. We can find the fringe width. Why? What is y? Y is called the fringe width. Y is called the fringe spacing. Y is called distance between the bright spots. Distance between the dark spots. So y is the distance. Y is the distance between the two dark spots, between the two bright spots. R, it is called the fringe width. So these are the names of y. So we can find the wavelength of light by this experiment, and we can find the fringe spacing between the two bright spots, or the two dark spots. Okay. Now look at the construction. Suppose this is the primary source. This is the slit S1. This is slit S1. This is the slit S2. And this is the screen. This is the screen. Okay, this is slit opening A. This is slit opening B. The distance between the slit and the screen is called L. L is the distance between the slit and screen. Okay. So these are the two opening A and B. The distance between the opening A and opening B is called D, small d. Small d is called the slit width. Small d is called the slit width or the slit separation or slit spacing or opening distance between opening A and okay. Why the slit S1 is used to diffract the light? Look at here. Look at the diagram. This is the diagram. Now we are studying its working. So the light will come and fall on the slit S1. When it fall on the slit S1, so the light will be get diffracted from the slit S1. When it diffracted from the slit S1, so that light will fall on the slit S2. So slit S2 has two opening. One is opening A, the other is opening B. So opening A, light will diffract from opening A, and light will be diffracted from opening B. So it means that both the light will overlap on one another. Look at here. The light is diffracted from opening A, the light is diffracted from opening B. So the two light when diffracted, so they will overlap to one another. When they are overlap, so first look at the condition of interference. Is they have the same frequency? Is they are coherent? Yes. They have the same frequency as well as they are coherent, because these are the lights of the same source. So these two lights which is diffracted from opening A and opening B are the two light of the same source. So if the source is same, so it means that their frequency will be same, they will be coherent. So look at here. We observe that at the middle The crust of one wave is fall upon the crust of other wave, the trough of one wave is fall upon the trough of other wave, the crust of one wave is fall upon the crust of other wave. So at the middle, we observed the bright spot is produced. Why the bright spot? Because the crust of one wave is fall upon the crust of other wave, the trough of one wave is fall upon the trough of other wave, the crust of one wave is fall upon the crust of other wave. So it means when we know that when the crust is fall upon the crust, when the trough is fall upon the trough, so it means that construct interference will occur, so a bright spot will produce. So remember, at the middle of the screen, we will observe the bright spots. Okay, so here the bright spot is produced at the middle, but when we look slightly up to the middle, slightly up to the bright spot, so here the crust will fall upon the trough, here the crust will fall upon the trough, here the crust fall upon the trough, so a dark spot will produce. Here it is also a dark spot, here it will bright spot, here it is a dark spot. So an alternative dark bright spot is producing on the screen. So it means that we will observe alternative dark bright spots will produce on the screen. Okay, so alternative dark bright will produce. So the distance between the two bright is called y, the distance between the two dark is called y, the distance between the bright and dark is called y. Okay, y is the distance between the two dark spots, the two bright spots, or the dark and bright spots. Okay, so we will observe alternating dark bright will produce. If someone asks you why the middle spot is bright at the middle, so look at the diagram again. This is source, primary source. This is slit S1. This is slit S2. This is the screen. Look at carefully, okay? So this is opening A, this is opening B. So whenever the light comes and fall on slit S1, so the light will be get diffracted and it will fall on A. Okay, look at this is the middle point O. This is the middle point O. So it means that the light will comes from A to O and B to O. So look at here carefully, very carefully. Suppose the light comes as in form of wave. Look, this is 1 lambda, this is 2 lambda, this is 3 lambda. So here the light covers 3 lambda distance from point O. So look at here. Now the light comes from B to O. So 1 lambda, 2 lambda, and 3 lambda. So here the light also covering 3 lambda, because in one cycle 1 lambda, in another cycle 2 lambda, in another cycle 3 lambda. So here the light is also covering 3 lambda distance and 3 lambda distance. So take the path difference. 3 lambda minus 3 lambda, so that is 0. So the path difference is 0. If the path difference between the two light is 0, then the constructive interference will occur and the bright spot will produce at the middle. So it means that it is following the condition of constructive interference. So that is why the middle spot is brighter on the screen. Okay, now look at the this experiment again. I'm going to draw this diagram again. So this is the primary source, this is the slit S1, and this is slit S2, and this is the screen. Okay, this is opening A, this is opening B. We know that the middle spot is always a brighter spot, so this point O is a brighter spot. Okay, now take another point P as brighter spot. Suppose there is another point P which has a bright spot, because there are alternating dark bright spots on the screen, so maybe there will be a bright spot. Okay, suppose there is a bright spot on the screen, so the light will come from A to P, that is called AP. This light is called AP, and the light comes from B to P, that light is called BP. So this is called BP. So if someone asks you, is the path of AP and BP are equal? So the answer is no, the path is not equal. So draw a perpendicular line on the BP. So if I draw the perpendicular line on BP, so look at here the perpendicular line. So I draw the perpendicular line of BP, so this is called Q. So if someone asks you AP and QP are equal, so the answer is yes. AP and QP are equal. So it means that in AP and in BP, the difference is BQ. So this is AP, this is BP. So the difference between AP and BP is BQ. So BQ is called S. S means the path difference. S means the path difference, and this is called the angle of diffraction, theta. Okay, this is the angle of diffraction, theta. And what is S? S is BQ, means the path difference between AP and BP. If we subtracted BQ, if we remove BQ, it means that both will have the same wavelength, both will have the same path. It means that BQ is the path difference between AP and BP. Okay, and the distance between P and O is called Y. Y is called the fringe width, Y is called the fringe spacing. So Y is the distance between O and P, the distance between the two bright spots. Okay, so this is called EO. This middle line is called EO. Okay, and we know that the distance between the slit and screen is called L, and the distance between opening A and opening B is called small d. Okay, small d means the slit width, the slit separation, and L is the distance between the slit and screen. Y is the distance between the two bright spots. Okay, now draw another line from E to P, that is called EP. That is called EP. So this is angle theta. This is angle theta. So we have two triangles, and these two triangles are congruent. These two triangles are congruent. How they are congruent? These can easily be proved by a theorem as you already studied in metric. By ASA postulates triangle ABQ is congruent to triangle EPO. Okay, look at the triangles. Look at the diagram carefully. This is ABQ. Look at the diagram. This is ABQ and this is EPO. Okay, this is EPO. I am going to dark it that you have seen it easily. Okay, so these two triangles are congruent. How these can be congruent? So you can easily prove by a theorem as you already studied in metric in mathematics. So by angle side angle postulate, these two triangles are congruent. So in that theorem in metric, we already studied when the triangles are congruent, their ratio of their sides will also be congruent. So it means that the perpendicular by hypotenuse of this triangle will be equal to perpendicular by hypotenuse of this triangle. So look at here. What is the perpendicular side here of ABQ? So the perpendicular side is BQ. What is the hypotenuse here? The hypotenuse is AB. Okay. What is the perpendicular side in EPO? So in EPO the perpendicular side is PO, and the hypotenuse side is EP. Okay. What is the value of BQ? So the value of BQ is called S. So putting S instead of BQ. And what is the value of AB? So look at AB. The distance from A to B is called small d. So putting D instead of AB. And what is PO? PO is called Y. So we will have equation number 1. This is equation number 1. Now, look at here. If we consider the Y is very small, what does it mean? It means that point P and point O should be get closer. If they are get closer, it means that Y will be very small. So look at the diagram again. So if I drag this point P downward, so if it is come here, so look at this. Suppose this is point P. So point O and point P are very close to one another. If point O and point P are very close to one another, so the Y is very small. So it means that this will be the EP. So EP and L will be equal. So EP and L both will be equal. So it means that if we consider the Y is very small, then EP will be equal to L. So putting in equation 1, what is equation 1? Look at equation 1 again. So it is S by D is equal to Y divided by EP. This is equation number 1. So putting the value of EP here, so it will be S by D is equal to Y divided by L. So cross multiply L on both sides. So it will be Y is equal to SL by D. This is the equation. This is the equation for the fringe spacing. This is the equation for the fringe spacing. Okay, now consider we have only bright spots on the screen. Suppose if I suppose there are bright spots on the screen, So we know that the path difference for the bright spot is m lambda. So putting the path difference here, so it will be y is equal to m lambda L divided by d. And what is m? M is a whole number 1 0 1 2 3 4 5 and so on. So putting the value of m here, so it will be 0 1 lambda, it will be 2, it will be 3. So putting the value of m here, so it will be 4 and so on. So these are the position of the bright spots. So this is called the central bright. Zero distance means this is the distance of central bright, and 1 lambda L by d is the distance of the first bright. This is the second bright, this is the third bright, this is the fourth bright. So these are the distances of the bright spots on the screen. Okay, now consider we are studying only dark spots on the screen. So if we study only dark spot on the screen, so we know that the path difference for the dark spots is m plus half lambda. So putting in the journal form, so we will get y is equal to m plus half lambda. M plus half lambda. What is m? M is a whole number. M is a whole number. So putting the value of m here, so we will get, putting m is 0, so it will be 0 plus 1 over 2, so it will be 1 over 2 lambda. So lambda L by 2d. Putting the value of m1 here, so it will be 3 lambda L by 2d. Putting the value of m is equal to 2, so 2 plus 1 over 2, it will be 5 by 2. 5 by 2 lambda L by d. 7 lambda L by 2d. 9 lambda L by 2d. So these are the position of the dark spots on the screen. So it means that this is not called the central bright, this is called the first dark, second dark, third dark, fourth dark. So it means that this is called the first dark. So for the first dark, you should put m is equal to 0. For the second dark, you should put m is equal to 1. For the third dark, this is the third dark. So for the third dark, you should put the m is equal to 2. For the fourth dark, you should put the m is equal to 3. So these are the dark spots, because the middle spot is the bright spot, the central bright. 0 is the central bright. So if you put m is equal to 0, so it will be the first dark, not the central dark or the zero dark. No, it will be the first dark. Okay, remember? So these are the position of the dark spots. If you want to find the position of the dark spot, where will be the dark spot, so you should know the lambda, L and D, so you can find the first dark, the second dark, the third dark and so on. So this is all about the young double slit experiment. If you have any question, then you can ask in comment section. Okay, take care. Allah Hafiz.